Hello and welcome to this discussion we're going to have about division, specifically division of polynomials. Now, as far as uses, I want to let you know why we're spending time on this. Those of you headed into your upper level mathematics or any sort of applied science, this is a skill you will be expected to have. Turns out that you've been multiplying polynomials together. It's now time to learn how to more effectively go the other way. You've actually already done that. When we talk about factoring, you're basically dividing a polynomial. We're just going to now extend that into a broader context. So a little bit of review first. I want you to understand how we're going to write our results. So let's take a look here at this first case, 125 divided by 5. So it may have been a while since you have done a division setup like this, but I'm going to say, all right, 5 goes into 12 twice, and then into 25 5 times. So we end up with 25. Notice there was no remainder here. So the 5 divides in evenly. That means 5 is a factor of 125, and it goes in there 25 different times. Okay. Well, over here then, let's take 45 divided by 8. Well, let's see. The 8 goes into 45 5 times, but then there's a little bit left over. Now, I want you to think about how we're going to deal with this remainder of 5. So 8 goes into 45 5 times with a remainder of 5, but 5 what's? Well, it's 5 eighths. And the way I know that is because I was dividing by 8. It's this many of this, 5 eighths. So what we're saying is, if I take this number times 8, it gets me back to 45. Same thing here. If I take the 25 times 5, it gets us back to 125. With that in mind, let's now take a look at the first method for dividing polynomials, which I'm calling the area model. Let's start off by multiplying these two together, and we're going to use the grid. The grid ends up being a fairly important thing. Okay, so across the top, a 2x plus 3, across the side, 5x plus 1. So take a moment, you multiply yours out, I'll multiply mine out, we'll see where we end up. Okay, so putting it all together then, I see 10x squared plus 17x's plus 3. You ended up in the same spot. Well, now, here is what we're going to be focusing on today, going in reverse. So starting with the division, we want to be able to get back to our end result. So if I take this product, which notice matches up nicely, and divide it by 2x plus 3, I should get the other factor. Namely, I need to end up with the 5x plus 1. Here's how your area model works. I'd like you to set up another grid. Now, how many spaces are in your grid is going to actually take a little bit of practice to become comfortable with. But basically, if this is a second degree and this is a first, that means I'm going to need a spot for an x to the first and a spot for a constant, so 2 spaces. So let's see what we have. I want you to, across the side here, put we call this the divisor. So I'm going to put my divisor over here, the 2x plus 3. Now leave the top empty. This is actually where we will write our quotient. And here now is how I want the process to work. I want to end up with 10x squared. So starting in this top left box, I'm going to write in 10x squared. And what you now need to ask yourself is, well, okay, to turn a 2x into a 10x squared, how much did I multiply by? To turn a 2 into a 10, you multiplied by 5. To turn an x into an x squared, you multiplied by x. Now use this up here to multiply by the plus 3 and fill in this bottom box. So 5 times 3x, that's my 15x. Now we're going to see a pattern along diagonals. So I now have all my x squareds taken care of. I have 15 of my x's taken care of. And I need 17 of them altogether. So how many are left? That means there are 2 others that are left. So I'm going to put that in this diagonal box, continuing this diagonal pattern, and do the same process. What do you multiply 2x by to turn it into a 2x? Well, you multiply by 1. Do the same thing then down here. Multiply to fill in the box. And what I'm going to see is that I now have all 17 x's taken care of. And for my constant, I need a 3, and I have it. So there is nothing left over. This divided in evenly, and my result, my quotient, is whatever is across the top. Now, as we move into our next several examples here, we're going to be following this same pattern. So divisor across the side, we're going to be looking at diagonals to see what we still need and take the process iteratively from there. Let's continue on with another example where we don't already know what the answer should be. You may be saying to yourself, hey, I think we just took a big step up here. I mean, kind of. Let's get our grid set up, though. So here's what I'm checking. If this is an x to the second, and this is an x to the fourth, you got to ask yourself, how many more x's are we going to need? So from second to fourth power, that's x to the second. I'm also going to then need a spot for x to the first, and a spot for my constant. So as I'm setting up my grid, I want to have 3 divisions going across. Looking at my divisor, it also has 3 terms, so I'm going to want 3 spaces down the side. Okay, then that means my grid is going to have 9 boxes. They are. Okay, divisor across the side, so x squared minus x minus 4. Let's always start in the upper left box. I want to end up with 7x to the fourth. So we now have to ask ourselves the question, all right, what did I multiply x squared by to get 7x to the fourth? Well, there's a factor of 7 I need. I've already got x to the second, so I need third, fourth, 2 more x's. I need an x squared to get us up to x to the fourth. There's the first term of our quotient. Next up, multiply this by this negative x, so negative 7x to the third. 7x squared times negative 4, that'd be negative 28x squared. Now remember, we're looking across diagonals to make sure we're accomplishing all our terms. So my x to the fourths, they're all taken care of. Done. For my x to the thirds, though, we currently have negative 7 of them. I need negative 11 of them, though, overall. So that means I need negative 4 more x to the thirds. So as I'm looking across this diagonal, this now has all negative 11 x cubes accounted for. Let's continue on then. So what did I multiply x squared by to turn it into negative 4x to the third? Well, I need a negative 4, and x to the second to x to the third needs another x. There that is. Let's then take negative 4x times the negative x. That gives us 4x squared. Negative 4x times negative 4 is 16x. So notice, everything in these grids should be the product of what's on the top times what's on the side. Okay, so I've got all my x to the thirds taken care of. Now we need to focus on our x squareds. So let's do some thinking. I've got negative 28x squareds plus 4x squareds, meaning I have negative 24x squareds right now. In order to get to negative 17x squareds, I've got to add on 7 more. So let's do that. I'm going to go to this box, add in my 7 more x squared, and see what we got. So x squared times 7x squared. Well, to turn it into 7x squared, I've got to multiply by a 7. Let's now recognize we've got those all taken care of. Multiply to fill these 2 boxes. So 7 times negative x is negative 7x. 7 times negative 4 is negative 28. Okay, now you'll notice here that our grid is all filled in. I think we're going to see that not everything divided in evenly this time, and so we're going to have a remainder. Here's how we deal with it. Just going to do a quick check. So 7x to the 4th, yes, I have that. Negative 11x to the 3rd. Negative 7 and negative 4, that's negative 11x to the 3rds. Negative 17x squared, so negative 28 plus 4 plus 7. So that's negative 28 plus 11, that's negative 17. Okay, all my x squareds are taken care of. Now let's see what we're missing. So 16x's minus 7x's is 9x's. Altogether, I need 17. So that means there are 8 extra x's that I don't have yet. So I'm just going to make a note here off to the side. I'm still missing 8 x's. So now on this diagonal, including the 8x, I have them all accounted for. Let's do the same thing now with our constant, with that negative 16. So I've got a negative 28. I need a negative 16, which means I'm 12 short. So over here off to the side, I'm going to put in a positive 12. Now, those together give me the negative 16 that I need. This is what a remainder looks like when you're dividing polynomials. So here's what I got. My quotient is the 7x squared minus 4x plus 7. And we're simply now going to add on the remainder. And just like when we did the 5/8 in that very beginning, your remainder here is going to show up as a fraction. Take what you have here. I've got 8x plus 12. And on the bottom, put in what your divisor is, the x squared minus x minus 4. And there you go. Now, this is one of those methods that I'm showing you first because, quite honestly, it's one of the easier ways to get there. Like with anything else, it does take practice to feel comfortable with it. So, what we have coming up next in this recording is just more examples of the same thing. So, you can continue through as many of them as you want, or if you're feeling super comfortable and confident, you can go and move into your own practice right now. Okay, with this next example, let's see what we have going on. I've got an x to the 3rd divided by an x to the 1st. So that means our quotient is going to start with, well, subtract the exponents, gives me x to the 2nd. So I need an x to the 2nd space, x to the 1st, and a constant. So that's 3 spaces across the top. Our divisor has 2 terms, so 2 spaces across the side. So our grid this time is going to be 2 tall and 3 across. Okay, across the side goes the divisor, the x plus 4. Now let's start filling some things out. I want to end up with 3x to the 3rds. So to make that happen, I need to make sure I multiply this x by a 3 and then an x to the 2nd. Let's take a look then. 3x squared times 4 would be 12x squared. Okay. Well, I got 12x squared. I need 13x squareds altogether. So we're 1 short. I need 1 more x squared. To turn an x into an x squared, I multiply by an x. That would give us a 4x down below. Now, I hope you notice there's no x to the son of a biscuit. There's no x term in our dividend. That's what the first part called is the dividend. That means that my x's together have to add up to 0. So if I've got 4 x's right now, and I want to have 0 x's, that means I've got to add on negative 4 x's. So to turn an x into a negative 4x, you multiply by negative 4. Negative 4 times 4 gives us negative 16. Okay, now let's make sure we have everything we need. So do I have 3x to the 3rds? Yes. 12x squared and x squared is 13x squared. 4x and negative 4x is 0 x's, which is what I need because there's no x term showing up here. I need a negative 7. I have a negative 16. Okay, that's not a problem. Just means there's going to be a remainder. We're going to put a number here now off to the side. So I've got negative 16. I want negative 7. The way that happens is by adding on 9 more. So I need a positive 9 as my remainder to make this constant diagonal work out. So here's our quotient. 3x squared plus x minus 4. And for your remainder, anything that ends up outside the box, just add on the remainder divided by the divisor. There it is. Believe it or not, once you do a couple of these, it actually ends up being kind of fun. Like you can make these up and have a good time with them. Okay, next up. Ooh, this looks a little nasty. That doesn't necessarily mean that it's going to be. So let's see what we need. X to the 5th divided by x to the 3rd. So that means subtract the exponents. That gives me 2. So I'm going to need a space for my squared, my first power, and my constant. So 3 across the top. This is only 2 terms. So that means I'm going to have what? 2 up and down. Okay. So let's go 2 up and down, 3 across. And by the way, if you ever count wrong, just add another column. It's not a big deal. So if you're not sure how many columns you're supposed to start with, just start with 1 or 2 and just keep adding as you go. Okay, divisor off to the side. And let's see what we have. All right, I need an x to the 5th. The way that happens is you multiply by an x squared. 5x squared times x squared is 5x to the 4th. So that one's taken care of. Next up, on the diagonal, I need 3x to the 4th. Currently got 5. That means I have 2 too many. So I need negative 2x to the 4ths. To turn an x cubed into negative 2x to the 4ths, I need a minus 2x. That down here is going to give us negative 10x to the 3rd. So 5 and negative 2, those add up to 3, so we're good there. Negative 10x to the 3rd, looking again on the diagonal, I need negative 5x to the 3rd. So I've got to give myself another positive 5x to the 3rds in order to make that happen. Negative 10 plus 5 gives me negative 5, checks out. To turn an x to the 3rd into a 5x to the 3rd, multiply by 5. 5 times 5x squared would be 25x squared. Ooh, that's actually super handy. So I've got this taken care of. I need 25x squareds, and I've got them. This one's also taken care of. Now, you'll notice I now have some leftover stuff, and there's no more spaces to fill. That just makes the remainder super easy to find. This is what's left over. I need negative 2x's. I don't have any x's. So there's part of my remainder. I need a plus 11. I don't have any constants in this table at all. So that is simply going to be part of the remainder. Let's put it all together. Your quotient is the top part. And then add on the remainder. There's a negative 2x and a plus 11 over x to the 3rd plus 5x squared. So on your practice, there are going to be a few problems that specifically ask you to use this method. Please do that. I want you to be able to practice the different methods so that you can find which one is easiest for you. Honestly, I really like this one. This is the one that I prefer, but that doesn't necessarily mean it's the one that you prefer, but you don't know unless you try. So give those a look, and thank you for sticking with me.